Hello there, and welcome to this quiet corner where curiosity gets cozy and the cosmos whispers its deepest secrets to slumber. I'm your host, and I'd love to know where in the world you're listening from and what time it is right now, because time itself is about to become far more mysterious than you might imagine. Tonight, we're going on a journey that spans from the very first moment of existence to the ultimate fate of everything. We're going to explore the echoes of the Big Bang, and by the time our cosmic adventure ends, you'll understand how time began and discover something absolutely shocking about how it all might end. But first, let me tell you about two men who accidentally stumbled upon the most important discovery in human history, and they almost threw it away thinking it was just bird droppings. Picture this, it's 1965, and two radio astronomers named Arno Penzias and Robert Wilson are working with a massive horn-shaped antenna in New Jersey. They're trying to eliminate this persistent, annoying hiss that keeps interfering with their work. For months, they've been frustrated by this static that seems to come from everywhere in the sky. No matter where they point their antenna, they clean the antenna. The hiss remains. They check their equipment. The hiss remains. They even climb up into the antenna itself and clean out what they delicately call white dielectric material left behind by pigeons. Still, the hiss remains. Little did they know, they were listening to the whisper of creation itself. That annoying static was the echo of the Big Bang, the leftover radiation from the moment the universe was born. They were hearing the sound of time beginning. Here's what's absolutely mind-blowing. You might think the universe has always existed, stretching infinitely into the past, but the truth is far more extraordinary. Everything you see, touch, and are made of was born in a moment so brief it makes a lightning flash seem like an eternity. The entire observable universe, spanning 93 billion light-years across and containing over 2 trillion galaxies, all emerged from something smaller than a proton. Right now, as you listen to these words, your body is being gently warmed by the afterglow of creation itself. Ancient light that has been traveling for over 13 billion years is touching your skin at this very moment. You are literally bathed in the echo of the Big Bang. But here's where our story takes an unexpected turn. Scientists recently discovered something that changes everything we thought we knew about the beginning and the end. They found that our universe isn't just expanding, it's accelerating. Something mysterious is pushing the fabric of space apart faster and faster, and nobody knows what it is. This discovery has led to a chilling realization about the fate of everything. In the far future, something called the Big Rip might tear apart every atom in the universe. Or perhaps time itself will simply fade away in what scientists call the heat death. But there's another possibility, one that's both terrifying and beautiful, and it involves a cosmic cycle that might mean our universe has died and been reborn countless times before. We'll explore this cosmic detective story together, but I'm getting ahead of myself. There's something else you need to know first, something that will change how you see yourself forever. Every atom in your body, except for hydrogen, was forged in the nuclear furnace of a dying star. You were literally made of stardust. When Carl Sagan said we are made of star stuff, he wasn't being poetic, he was being scientifically precise. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created in stellar explosions that happened billions of years ago. But the story gets even more incredible. Those hydrogen atoms that make up most of your body, they're even older. They were created in the first few minutes after the Big Bang, when the universe was so hot and dense that it was essentially one giant nuclear reactor. So you're not just in the universe, you are the universe. You're a walking, talking, conscious piece of the cosmos that has somehow become aware of itself. And tonight, we're going to trace your atoms back to their very beginning, to the moment when time itself switched on. If you find yourself drifting off during our cosmic journey, that's perfectly fine. Sometimes the most profound truths are best absorbed in that gentle space between waking and sleeping. What we're about to explore might just change how you see yourself and your place in this vast, beautiful universe. So get comfortable. Let your mind wander among the stars and prepare to discover the echoes of the very moment time began. But remember, this story has a twist ending that even the smartest scientists on Earth are still trying to figure out. Now that I've got you thinking about those two confused scientists listening to the echo of creation, let me take you back to where this incredible story really begins. Because what Penzias and Wilson discovered wasn't just static, it was proof of the most extraordinary moment in the history of everything. Picture the universe, 13.8 billion years ago. There was no space as we know it, no time ticking by, no matter, no energy, no anything. Just a single point of infinite density and temperature that scientists call a singularity. This wasn't a point floating in empty space, because there was no space. This point was everything, and everything was about to explode into existence. But here's where the story gets really wild. The Big Bang wasn't an explosion in space, it was an explosion of space itself. Imagine trying to explain to someone what north means when they're standing at the North Pole. That's what it's like trying to understand what existed before the Big Bang. Because before didn't exist yet. In the first unimaginably tiny fraction of a second, something incredible happened. The universe didn't just expand, it underwent what scientists call cosmic inflation. In less time than it takes light to travel across a proton, the universe doubled in size over and over again, at least 60 times. That's like a grain of sand suddenly becoming larger than a basketball, then larger than Earth, then larger than the solar system, all in a time span so brief that calling it an instant would be a massive overstatement. During this mind-bending expansion, the temperature was so extreme that it makes the core of the hottest stars look like a freezer. We're talking about temperatures of 1 trillion degrees. At these temperatures, the very fabric of reality behaved differently. The four fundamental forces that govern everything in our universe today, gravity, electromagnetism, and the strong and weak nuclear forces, were all unified into a single superforce. As the universe continued to expand and cool, these forces began to separate out, like oil separating from water. First gravity split off, then the strong nuclear force, then the weak nuclear force, and electromagnetism separated. This wasn't just academic physics. This was the universe literally deciding what the rules of reality would be. Here's something that will blow your mind. In the first 3 minutes after the Big Bang, the entire universe was like the inside of a giant star. The temperature and pressure were so intense that nuclear fusion was happening everywhere at once. This is when the first hydrogen and helium atoms were forged, the same elements that would later become the fuel for the first stars. But the universe had a problem. It was so hot and dense that light couldn't travel anywhere. Photons, the particles of light, would bounce around constantly, scattered by the thick soup of particles filling space. The universe was essentially opaque, like trying to see through thick fog, for 380,000 years. The universe remained dark and foggy. Then something beautiful happened. The temperature dropped enough for electrons to start sticking to atomic nuclei, forming the first complete atoms. Suddenly, light could travel freely through space for the first time. The universe became transparent. And that first light is still racing through the cosmos today. This is the light that Penzias and Wilson accidentally discovered. The cosmic microwave background radiation is literally the afterglow of the moment the universe became transparent. It's the oldest light in the universe, and it's everywhere around us. A faint whisper of that incredible moment when the cosmos first began to shine. But here's the part that should give you goosebumps. This ancient light isn't just some distant historical curiosity. It's touching you right now. Every second, about 400 million photons from the Big Bang pass through your body. You're not just learning about cosmic history, you're physically connected to it. The story gets even more remarkable when you realize that tiny, almost imperceptible ripples in this ancient light became the seeds of everything we see today. Those microscopic variations in temperature and density, smaller than 1 part in 100,000, were the blueprints for galaxy clusters, stars, planets, and ultimately, for you. Think about this. The device you're listening to this on, the chair you're sitting in, the air you're breathing, all of it traces back to those first moments after the Big Bang. Every atom around you has been on a 13.8 billion year journey through space and time, cycling through countless stars and cosmic events, all leading to this moment when you're learning about where it all came from. And this is just the beginning of our story. Because those early moments set up a cosmic drama that's still playing out today, with a plot twist that's going to change everything you thought you knew about the fate of the universe. Now that you understand the universe began from a single point and expanded into the cosmos we see today, let me tell you about the incredible mechanisms that made this all possible. Because what happened in those first moments wasn't just expansion, it was the most spectacular choreographed dance of physics that has ever occurred. Remember that cosmic inflation I mentioned? Here's how mind-bendingly fast it really was. In the time it takes light to travel from one side of a proton to the other, the universe doubled in size. Then it doubled again, and again, and again, at least 60 times in total. To put this in perspective, if a single atom suddenly inflated at this rate, it would become larger than a grapefruit in that same impossibly brief instant. This wasn't just the universe getting bigger. This was space itself being created. Every cubic inch of emptiness around you right now was stretched into existence during those first moments. The very concept of distance, of here and there, was being born. But why did this happen? The answer lies in something called a quantum field, an invisible energy that filled all of space during those first moments. Think of it like a ball sitting on top of a hill. The ball is unstable and wants to roll down to the bottom, but for a brief moment, it can balance at the top. When it finally rolls down, it releases all that stored energy, and in the case of the universe, that energy became the explosive force of inflation. As the universe expanded and cooled, something remarkable happened. The 4 fundamental forces that govern everything in our reality began to separate from each other. At the very beginning, gravity, electromagnetism, and the strong and weak nuclear forces were all unified into a single superforce. But as the temperature dropped, they began to split apart, like dancers leaving the stage one by one. First, gravity separated out. This is the force that keeps your feet on the ground and holds the planets in orbit around the sun. Then the strong nuclear force split off. This is what holds the protons and neutrons together in atomic nuclei. Next came the weak nuclear force, which governs radioactive decay. Finally, electromagnetism became its own distinct force, giving us light, radio waves, and the magnetic fields that protect our planet. The timing of these separations was crucial. If they had happened even slightly differently, the universe would have been a very different place. Stars might never have formed, or atoms might have been unstable. The fact that everything worked out just right to create a universe where complexity and life could emerge is one of the deepest mysteries in cosmology. As the universe continued to expand and cool, we enter what scientists call the nucleosynthesis era. For about 20 minutes, the entire universe was hot and dense enough to act like a giant nuclear reactor. Protons and neutrons crashed into each other, fusing together to form the first atomic nuclei. This process created hydrogen and helium, the two lightest elements, in almost exactly the proportions we observe in the universe today. But here's something fascinating. Despite this cosmic nuclear reactor running for 20 minutes, it could only create the lightest elements. Everything heavier than helium, including the carbon in your body, the oxygen you breathe, and the iron in your blood, would have to wait millions of years to be forged in the hearts of the first stars. For the next 380,000 years, the universe remained in what scientists call the Dark Ages. It wasn't actually dark because there was plenty of light, but that light couldn't travel very far. The universe was filled with a thick fog of free electrons and protons, and every time a photon tried to travel through space, it would bounce off one of these particles like a pinball. Then came one of the most beautiful moments in cosmic history. The temperature had dropped enough for electrons to start sticking to protons, forming the first complete hydrogen atoms. Suddenly, the fog cleared. Light could travel freely through space for the first time. The universe became transparent, and that first light began a journey that continues today. This is the light that's all around us right now, the cosmic microwave background radiation. It's been traveling through space for nearly 14 billion years, carrying information about what the universe looked like when it was only 380,000 years old. It's like having a baby picture of the entire cosmos. But hidden within this ancient light were tiny variations, ripples of temperature and density that were almost impossibly small. These ripples would become the seeds of every structure in the universe. Where the ripples were slightly denser, gravity would eventually pull matter together to form the first stars and galaxies. Where they were slightly less dense, vast empty spaces would remain. The stage was now set for the next act in our cosmic drama, where these tiny seeds would grow into the magnificent structures we see in the night sky today. To truly understand the magnitude of what we're talking about, we need to zoom out and grasp the incredible scales involved in this cosmic story. Because the numbers aren't just big, they're so mind-breakingly enormous that they challenge our very ability to comprehend them. Let's start with size. In the first second after the Big Bang, the observable universe grew from smaller than a subatomic particle to roughly the size of a grapefruit. That might not sound impressive until you realize we're talking about an increase of about 10 to the power of 26. That's a 1 followed by 26 zeros. To put this in perspective, there are only about 10 to the power of 23 stars in the observable. The universe grew by a factor larger than the number of stars it would eventually contain, but the size expansion was just the beginning. Consider the temperature changes. In the first moment, the universe was hotter than 10 to the power of 32 degrees Kelvin. That's a temperature so extreme that if you wrote it out in full, the number would have 32 digits. The core of our sun, by comparison, is only about 15 million degrees. The early universe was trillions of trillions of trillions of times hotter than that. Now here's where it gets really mind-bending. All of this happened in the first second, but that first second contained more dramatic change than the entire rest of the universe's history. In fact, most of the really important stuff happened in the first tiny fraction of a second. The cosmic inflation that created space itself occurred in the first 10 to the power of negative 32 seconds. That's a decimal point followed by 31 zeros and then a 1 dot to help you grasp this timescale. Consider this: the ratio of that first moment of inflation to 1 second is roughly the same as the ratio of 1 second to the age of the universe. In other words, that first moment was as brief compared to a second as a second is, compared to 13.8 billion years. But here's what's truly extraordinary. During that impossibly brief moment, the universe created more space than it has created in all the billions of years since. The expansion we see today, with galaxies rushing away from each other, is actually the universe coasting on the momentum from that first moment of inflation. The energy involved in this process is equally staggering. Scientists estimate that the energy density during inflation was around 10 to the power of 76 joules per cubic centimeter. To put that in perspective, if you could somehow compress all the energy that flows from the sun in an entire year into a space the size of a sugar cube, it still wouldn't come close to matching the energy density of the early universe. This incredible energy had to go somewhere, and it went into creating matter. Einstein's famous equation, E equals mc squared, tells us that energy and matter are interchangeable. The universe literally converted its initial energy into the particles that would eventually become stars, planets, and people. Every atom in your body has been on an incredible journey. The hydrogen atoms that make up about 60% of your body were created in the first few minutes after the Big Bang. They've been floating through space for nearly 14 billion years, cycling through multiple generations of stars, dispersing into interstellar space, and eventually finding their way into the molecular clouds that formed our solar system. The heavier elements in your body have an even more dramatic story. The carbon that forms the backbone of your DNA, the oxygen that you breathe, the calcium in your bones, the iron in your blood. All of these were forged in the nuclear furnaces of massive stars. When those stars died in spectacular supernova explosions, they scattered these elements throughout the galaxy, where they eventually became part of new stars, planets, and ultimately, This means you're not just connected to the universe. You are the universe. You're a collection of atoms that have been on a 13.8 billion year journey through space and time. Some of the atoms in your left hand might have been forged in a different star than the atoms in your right hand. You're literally a walking, talking piece of the cosmos that has somehow become conscious and is now learning about its own origins. The cosmic microwave background radiation that we talked about earlier is still all around us, a faint whisper from the universe's infancy. About 400 million photons from the Big Bang pass through your body every second. You're not just learning about cosmic history, you're physically immersed in it. But the connections go even deeper. The tiny quantum fluctuations in the early universe, variations so small they were only 1 part in 100,000, became the seeds of the cosmic web we see today. These microscopic ripples in the fabric of space-time grew over billions of years into the largest structures in the universe: galaxy clusters, filaments of matter stretching across hundreds of millions of light years, and vast empty voids between them. And here's where our story takes another fascinating turn, because these connections reveal something profound about the nature of time itself. The story of how we discovered the Big Bang is almost as remarkable as the Big Bang itself. It's a tale of brilliant minds, heated debates, and discoveries that completely overturned our understanding of the universe. But it's also a story about human nature, about our reluctance to accept ideas that challenge our deepest assumptions about reality. For most of human history, people believed the universe was eternal and unchanging. The stars seemed fixed in their patterns, the cosmos appeared static and stable. Even Albert Einstein, when he developed his theory of general relativity in 1915, assumed the universe was static, when his equations suggested the universe should be either expanding or contracting. He was so uncomfortable with this idea that he added a mathematical term called the cosmological constant to force his equations to describe a static universe. He later called this his greatest blunder. But the universe had other plans. In the 1920s, an astronomer named Edwin Hubble made observations that would shatter the idea of a static cosmos forever. Using the most powerful telescope of his time, Hubble discovered that the fuzzy patches of light that astronomers called nebulae were actually entire galaxies, enormous collections of stars far beyond our own Milky Way. Even more shocking, Hubble found that these galaxies were moving away from us, and not just moving randomly, but moving in a very specific pattern. The farther away a galaxy was, the faster it was receding. This could only mean one thing: the universe was expanding. But if the universe is expanding now, that means it was smaller in the past. And if you follow that logic back far enough, you reach a point where everything was compressed into a single, incredibly dense point. This was the insight that led to the Big Bang Theory. The idea was first proposed by a Belgian priest and physicist named Georges Lemaitre in 1927. He called it the cosmic egg, and suggested that the universe began as a single atom that somehow exploded into existence. Most scientists of the time found this idea ridiculous. The very notion that the universe had a beginning seemed to violate everything they thought they knew about physics. The debate raged for decades. On one side were the Big Bang theorists, led by scientists like George Gamow and Ralph Alpha. On the other side were the steady-state theorists, led by Fred Hoyle, Herman Bondi, and Thomas Gold. The steady-state theory suggested that the universe was indeed expanding, but that new matter was constantly being created to fill in the gaps, keeping the overall density constant. In this model, the universe had no beginning and no end. It had always existed and always would. Ironically, it was Fred Hoyle, one of the biggest opponents of the Big Bang Theory, who gave it its name. During a BBC radio broadcast in 1949, dismissively referred to Lemaitre's idea as this Big Bang Theory. He meant it as an insult, but the name stuck. The steady-state theory was elegant and philosophically appealing. It avoided the uncomfortable question of what came before the beginning, but it made a crucial prediction. If the universe had no beginning, then it should look roughly the same at all times and in all directions. The Big Bang Theory made a different prediction. If the universe began in a hot, dense state, there should be leftover radiation from that initial fireball, cooled by billions of years of expansion. This is where Penzias and Wilson enter our story. In 1965, while trying to eliminate that persistent static from their antenna, they unknowingly discovered the cosmic microwave background radiation. This was the smoking gun that proved the Big Bang theory correct. The steady-state theory couldn't explain this radiation, but the Big Bang theory had predicted it exactly. But the discoveries didn't stop there. In the 1990s, the COBE satellite created the first detailed map of the cosmic microwave background. For the first time, scientists could see the tiny variations in temperature that represented the seeds of all cosmic structure. It was like looking at the universe's baby picture, taken when it was only 380,000 years old. More recent missions, like the Wilkinson Microwave Anisotropy Probe and the Planck satellite, have measured these variations with incredible precision. They've allowed us to determine the age of the universe to, within a few million years, to map the distribution of matter and energy, and to understand the composition of the cosmos with unprecedented accuracy. These discoveries revealed something surprising: the ordinary matter that makes up stars, planets, and people accounts for only about 5% of the universe. About 27% is dark matter, invisible particles that interact only through gravity. The remaining 68% is dark energy, a mysterious force that's causing the expansion of the universe to accelerate. This brings us to the most recent twist in our cosmic story, a discovery that has profound implications for the ultimate fate of everything. Despite all our discoveries, despite having baby pictures of the universe and knowing its age to incredible precision, we've stumbled upon mysteries so profound that they challenge our fundamental understanding of reality itself. And these mysteries aren't just academic curiosities, they hold the key to understanding how everything might end. Let's start with the singularity problem. When we trace the Big Bang back to its very beginning, our physics breaks down completely. At the moment of the singularity, density becomes infinite, temperature becomes infinite, and the curvature of space-time becomes infinite. Whenever physicists encounter infinities in their equations, it's usually a sign that something is wrong with their understanding. The truth is, we don't know what happened at the exact moment of the Big Bang. We can trace the universe's history back to about 10 to the power of negative 43 seconds after the beginning, a time called the Planck epoch. Before that, our current theories of physics simply don't apply. We need a theory of quantum gravity, a way to unite Einstein's general relativity with quantum mechanics. But despite decades of effort, physicists haven't been able to create such a theory. This means that the most important moment in the history of everything remains completely mysterious to us. We know what happened after the universe began, but we don't know how or why it began in the first place. Then there's the mystery of cosmic inflation. We know that the universe underwent this period of rapid expansion, but we don't know what caused it. Scientists have proposed the existence of a field called the inflaton, but we've never detected it. We don't know what it's made of, how it works, or why it suddenly started and stopped. Even more puzzling, inflation theory suggests that our observable universe might be just a tiny bubble in an infinite cosmic foam. If inflation happened once, it probably happened many times, creating countless other universes, each with potentially different laws of physics. This idea, called the multiverse, is impossible to test directly, but it raises profound questions about the nature of reality. But perhaps the deepest mystery of all is the composition of our universe. When astronomers first mapped the cosmic microwave background and studied the rotation of galaxies, they discovered that there wasn't enough ordinary matter to account for what they were seeing. Something invisible was providing additional gravitational pull, something that doesn't emit, absorb, or reflect light. They called it dark matter. Dark matter makes up about 27% of the universe, more than 5 times as much as ordinary matter. It's all around us, streaming through your body right now, but we can't see it or feel it. Despite decades of searching, we still don't know what dark matter is made of. It could be exotic particles left over from the Big Bang, or it could be something even stranger. But dark matter isn't the strangest component of our universe. That distinction belongs to dark energy, which makes up about 68% of everything. Dark energy is even more mysterious than dark matter because it doesn't just sit there invisibly. It actively pushes space apart, causing the expansion of the universe to accelerate. This discovery, made in 1998 by studying distant supernovas, was completely unexpected. Scientists thought that gravity should be slowing down the expansion of the universe, not speeding it up. Instead, they found that the universe's expansion has been accelerating for the past 5 billion years or so. Nobody knows what dark energy is or why it exists. It could be a property of space itself, a field that permeates all of reality, or something even more exotic. What we do know is that it's becoming more dominant as the universe expands, and this has profound implications for the future. Imagine floating in the gentle darkness between stars, surrounded by the soft glow of distant galaxies. The cosmic microwave background wraps around you like a warm blanket woven from the light of creation. In this peaceful vastness, time moves differently. 1 billion years passes like a single breath. You are cradled in the embrace of infinity, where every question leads to deeper wonder. These mysteries don't diminish the beauty of what we know, they enhance it. Like a cosmic lullaby, the universe whispers its secrets while keeping its deepest truths gently veiled. In not knowing everything, we preserve the capacity for eternal wonder. The unknown stretches before us like an infinite ocean, and we've barely dipped our toes in the water. But what we have discovered points towards something extraordinary about the ultimate fate of everything. Something that will determine whether the universe ends in fire, ice, or something far more strange. You might be wondering how this cosmic story affects your daily life. After all, the Big Bang happened nearly 14 billion years ago, and the mysteries of dark matter and dark energy seem impossibly distant from your everyday concerns. But the truth is, this cosmic knowledge touches every aspect of your existence in ways both practical and profound. Let's start with something as simple as finding your way home. The GPS system that guides you through traffic depends on satellites orbiting Earth at incredible speeds. But here's the thing. Time passes differently for those satellites than it does for you. According to Einstein's theory of relativity, which grew out of our understanding of space and time from Big Bang cosmology, time runs slightly faster for objects in weaker gravitational fields and slower for objects moving at high speeds. Without accounting for these relativistic effects, GPS would be off by about 6 miles every single day. The satellite's clocks have to be constantly adjusted based on principles that Einstein derived from thinking about the nature of space and time. So every time you successfully navigate to a new restaurant or find your way to a friend's house, you're relying on our understanding of cosmic physics. The medical technologies that save lives every day also depend on our cosmic knowledge. Radioactive dating techniques, which help doctors trace the progress of treatments through your body, are based on our understanding of nuclear physics that came from studying the Big Bang MRI. Machines use principles of quantum mechanics that were developed while trying to understand the behavior of particles in the early universe. Even the energy that powers your home has cosmic connections. Nuclear power plants work by recreating, in a controlled way, the same fusion processes that occurred in the first few minutes after the Big Bang. Solar panels capture energy from fusion reactions happening in the sun's core. Reactions that follow the same principles that governed the universe's first nuclear processes. But the implications go far beyond technology. Understanding your cosmic origins can fundamentally change how you see yourself and your place in the world. When you truly grasp that you are made of stardust, that every atom in your body was forged in the nuclear furnace of a dying star, it creates a sense of connection to something larger than yourself. This cosmic perspective can be incredibly therapeutic. When you're stressed about work, deadlines, or relationship problems, remembering that you're part of a story that spans 13.8 billion years can put things in perspective. Your problems are real and important, but they're also temporary blips in the vast sweep of cosmic time. Many people find that understanding their cosmic heritage helps them sleep better. There's something deeply comforting about knowing that you're part of an ancient process, that your atoms have been on an incredible journey through space and time. When you close your eyes at night, you can imagine yourself floating in the cosmic web, connected to every star and galaxy in the universe. The knowledge that you are literally bathed in the afterglow of the Big Bang can also be a source of comfort. The cosmic microwave background radiation that touches your skin carries information from the universe's infancy. You're not separate from the cosmos, you're intimately connected to it. This connection persists whether you're aware of it or not. But awareness of it can bring peace. Understanding cosmic timescales can also help you appreciate the present moment. The odds of your existence are astronomically small. It took nearly 14 billion years of cosmic evolution, the death and rebirth of multiple generations of stars, the formation of our solar system, the development of life on Earth, and countless other improbable events for you to exist at this moment. From a cosmic perspective, your life is both incredibly brief and incredibly precious. You're a temporary arrangement of atoms that the universe has organized into a conscious being capable of understanding its own origins. This knowledge doesn't make you insignificant, it makes you miraculous. The fact that the universe has evolved to the point where it can understand itself through beings like you is one of the most remarkable aspects of cosmic evolution. You're not just in the universe, you're the universe becoming aware of itself. Your thoughts about the Big Bang are the universe contemplating its own beginning. This cosmic perspective can also inspire a sense of responsibility. If you truly understand that you're part of an ancient cosmic process, it becomes harder to take the Earth and its environment for granted. You're not just a consumer of resources, you're a conscious participant in the ongoing story of cosmic evolution. The atoms that make up your body will outlast you by trillions of years. Long after you're gone, they'll continue their journey through space and time, perhaps becoming part of new stars, new planets, maybe even new forms of life. In this sense, you're immortal, not as an individual consciousness, but as a collection of matter and energy that will persist for the lifetime of the universe. This knowledge can bring comfort in the face of mortality, and meaning in the face of apparent insignificance. You're part of something vast and beautiful, something that connects you to every other conscious being in the universe. When we step back and look at the Big Bang, not as an isolated event, but as part of a larger cosmic story, we begin to see patterns and connections that reveal something profound about the nature of existence itself. The universe isn't just a collection of random events. It's a magnificent, unfolding process where simple rules create infinite complexity. Consider the journey from the cosmic egg to consciousness. In the beginning, there was just energy and the for fundamental forces. From this incredibly simple starting point, the universe has evolved into a place where atoms can organize themselves into molecules, molecules into cells, cells into organisms, and organisms into beings capable of contemplating their own origins. This is emergence on a cosmic scale. The same physical laws that governed the first moments after the Big Bang also govern the formation of stars, the evolution of life, and the firing of neurons in your brain. Gravity, which separated from the other forces in the universe's first moments, is what allows stars to form and planets to orbit. The electromagnetic force governs the chemistry that makes life possible. The strong nuclear force holds atomic nuclei together, and the weak nuclear force drives the radioactive decay that keeps Earth's core molten and maintains our planet's magnetic field. This unity of physical law across all scales of existence suggests something profound about the nature of reality. The universe isn't just a collection of separate objects floating in empty space. It's a single, interconnected system where everything influences everything else. The quantum fluctuations in the early universe became the seeds of galaxies. The deaths of the first stars provided the heavy elements necessary for rocky planets and life. The evolution of life on Earth has changed our planet's atmosphere and continues to influence its climate. From this perspective, the traditional boundaries between physics, chemistry, biology, and consciousness begin to dissolve. They're all aspects of the same underlying cosmic process. You're not a biological organism that happens to live in a physical universe. You're a physical process that has become complex enough to be biological and, ultimately, conscious. This interconnectedness extends to the question of time itself. Einstein showed us that time isn't a universal constant ticking away in the background. It's woven into the fabric of space, and it can be stretched and compressed by gravity and motion. The time you experience is intimately connected to your motion through space and your position in gravitational fields. But there's an even deeper connection. The arrow of time, the fact that we experience time as flowing from past to future, is intimately connected to the expansion of the universe. Some physicists believe that time's direction is determined by the universe's expansion. If the universe were contracting instead of expanding, time might run backward. This raises profound questions about the nature of consciousness and free will. If time is emergent from the universe's expansion, and if consciousness is emergent from complex arrangements of matter, then in some sense, your ability to contemplate these questions is the universe's expansion becoming aware of itself. The anthropic principle suggests that the universe's physical constants seem remarkably fine-tuned for the emergence of complexity and consciousness. If the strength of gravity was slightly different, stars might not form. If the electromagnetic force was slightly stronger or weaker, atoms might not be stable. If the expansion rate of the universe was slightly different, matter might never have clumped together to form galaxies. This fine-tuning is either an incredible coincidence, evidence of some kind of design, or a selection effect in a multiverse where countless universes exist with different physical constants. We observe these particular values because we exist in a universe where they allow for the emergence of observers like us. But perhaps the most profound implication of our cosmic story is what it tells us about meaning and purpose in a universe that began with the Big Bang and may end in heat death or a big rip. Where does meaning come from? The answer may be that meaning isn't something the universe has, but something the universe does. Through conscious beings like you, the universe has evolved to the point where it can contemplate its own existence, question its own nature, and create beauty and meaning through conscious experience. Every time you feel wonder at a sunset, love for another person, or curiosity about the cosmos, you're participating in the universe's ongoing process of self-discovery. As we drift deeper into our cosmic contemplation, we begin to sense that we're part of something much larger than ourselves, something that connects us to every star and galaxy in the night sky. The universe's story is our story, and our story is the universe's story. In this gentle realization, we find both humility and profound significance. The dance of cosmic evolution continues. And we're not just observers of this dance, we're participants in it. Through our consciousness, the universe has developed the ability to understand itself, to appreciate its own beauty, and to ponder its own mysteries. As we stand at the edge of our current understanding, scientists around the world are pushing the boundaries of what we know about the universe's beginning and ultimate fate. The discoveries being made today are as revolutionary as anything in the history of cosmology, and they're pointing toward possibilities that would have seemed like science fiction just a few decades ago. One of the most exciting developments is the detection of gravitational waves, ripples in the fabric of space-time itself. In 2015, the LIGO detectors successfully measured these incredibly tiny distortions caused by colliding black holes. But scientists are now building even more sensitive instruments that might be able to detect gravitational waves from the Big Bang itself. These primordial gravitational waves would carry information about the universe's first moments, potentially allowing us to peer back to the very instant of cosmic inflation. The James Webb Space Telescope, launched in 2021, is already revolutionizing our understanding of the early universe. This incredible instrument can see farther into space, and therefore farther back in time, than any telescope before it. It's observing the first galaxies that formed after the Big Bang, watching star formation in unprecedented detail, and studying the atmospheres of planets around other stars. Some of the galaxies it's discovered are so massive and well-formed that they're challenging our understanding of how quickly structure could form in the early universe. But perhaps the most mind-bending research involves the search for dark matter and dark energy. Deep underground, in former mines and specially constructed laboratories, scientists are running experiments to detect dark matter particles. These detectors are so sensitive that they have to be shielded from cosmic rays, radioactivity, and even the vibrations from passing trucks. If they succeed in directly detecting dark matter, it would be one of the most important discoveries in physics. The search for dark energy is equally fascinating. Scientists are using advanced techniques to map the three-dimensional structure of the universe, studying how dark energy has influenced the growth of cosmic structures over billions of years. They're discovering that dark energy might not be constant, that its effects might be changing over time. This could have profound implications for the universe's future. Quantum cosmology is another cutting-edge field that's beginning to yield insights into the universe's origin. By applying quantum mechanics to the universe as a whole, scientists are exploring the possibility that the Big Bang wasn't a unique event, but part of an eternal cycle of cosmic death and rebirth. In some models, our universe might be one bubble in an infinite multiverse, with new universes constantly being born through quantum fluctuations. The concept of cosmic inflation is also being refined. Scientists are testing different models of inflation, looking for signatures in the cosmic microwave background radiation that could tell us exactly how inflation occurred. Some models suggest that inflation creates a fractal universe where new regions of space-time are constantly inflating, creating an endless branching structure of universes. Artificial intelligence is accelerating these discoveries. Machine learning algorithms are analyzing vast amounts of data from telescopes and particle detectors, finding patterns that human scientists might miss. AI is helping to simulate the evolution of the universe, model the behavior of dark matter and dark energy, and even design new experiments to test our theories. Looking toward the future, scientists are planning even more ambitious projects. The European Space Agency is developing the LISA mission, a space-based gravitational wave detector that will be sensitive enough to detect the merger of supermassive black holes throughout the universe. NASA is planning new space telescopes that will map dark energy with unprecedented precision. On the theoretical front, physicists are making progress toward a theory of quantum gravity, the holy grail of physics that would unite general relativity with quantum mechanics. String theory, loop, quantum gravity, and other approaches are all being explored. Success in this area could finally allow us to understand what happened at the moment of the Big Bang. These advances are also revealing new possibilities for the universe's ultimate fate. The discovery that the universe's expansion is accelerating has led to several scenarios for how everything might end. In the heat-death scenario, the universe continues expanding and cooling until all the stars burn out and even black holes evaporate. In the Big Rip scenario, dark energy eventually becomes so strong that it tears apart all matter, even atoms themselves. But there are other possibilities. If dark energy changes over time, it might eventually reverse the expansion, leading to a big crunch where the universe collapses back on itself. Some theories suggest that such a collapse might trigger another Big Bang, creating a cyclic universe that has no beginning and no end. Even more exotic possibilities are being explored. Some scientists speculate that sufficiently advanced civilizations might be able to manipulate the structure of space-time itself, possibly creating new universes or escaping the heat death of our own. Others suggest that consciousness itself might play a role in the universe's evolution, that the observer effect in quantum mechanics might have cosmic implications. These aren't just abstract theoretical possibilities. They represent the next chapter in humanity's greatest adventure, the quest to understand our cosmic origins and destiny. As we near the end of our cosmic journey together, it's time to reflect on what all of this means for you personally, because this isn't just an abstract story about distant galaxies and ancient events. This is your story, the story of how you came to exist in this magnificent universe, and what your existence means in the context of cosmic time. Think about this remarkable fact. You are currently experiencing the universe at a very special moment in its history. You exist during the brief cosmic era when stars are shining, when planets can harbor life, when the universe is old enough for complex chemistry but young enough for stellar fusion. In the vast sweep of cosmic time, this era is incredibly brief. You're witnessing the universe during its most interesting and vibrant phase. Your existence required an almost impossible chain of events. The Big Bang had to unfold in exactly the right way to create a universe with the right physical constants. The first stars had to form and die, creating the heavy elements necessary for rocky planets and life. Our solar system had to form in just the right location in the galaxy, with Earth at just the right distance from the Sun. Life had to evolve from simple chemicals to complex organisms over billions of years. Your ancestors had to survive countless challenges, disasters, and evolutionary pressures. The odds against your existence are so astronomically small that they're essentially zero. Yet here you are, a conscious being capable of contemplating the very forces that created you. In a very real sense, you're the universe becoming aware of itself. Every time you look up at the stars with wonder, every time you feel awe at the beauty of nature, every time you contemplate the mysteries of existence, you're participating in the universe's ongoing process of self-discovery. This perspective can be both humbling and empowering. On one hand, it reminds us that we're part of something much larger than ourselves, that our individual concerns are brief fluctuations in the vast ocean of cosmic time. On the other hand, it reveals that consciousness, like yours, is perhaps the most remarkable phenomenon in the universe. You're not just made of star stuff, you're star stuff that has learned to think, to feel, to love, to create meaning. Consider the atoms in your body. The hydrogen was forged in the first few minutes after the Big Bang, when the universe was a hot, dense soup of particles. The carbon, nitrogen, and oxygen that make up most of your body were created in the nuclear furnaces of massive stars that lived and died billions of years ago. The iron in your blood was forged in the explosion of a supernova, one of the most violent events in the universe. These atoms have been on an incredible journey. They've drifted through interstellar space, been part of molecular clouds, condensed into new stars and planets, and eventually found their way into the chemistry of life on Earth. They've been part of countless other organisms before becoming part of you, and after you're gone, they'll continue their journey, perhaps becoming part of new life forms, new stars, new worlds. In this sense, you're not just a temporary arrangement of matter. You're a conscious moment in the ongoing story of cosmic evolution. Your thoughts and experiences are the universe's way of knowing itself. When you feel wonder at a sunset, that's hydrogen atoms forged in the Big Bang experiencing beauty. When you feel love for another person, that's star stuff recognizing star stuff. When you contemplate the mysteries of existence, that's the cosmos pondering its own nature. This cosmic perspective can bring profound comfort, especially when facing life's inevitable challenges. Your problems are real and important, but they're also temporary ripples in the vast ocean of space and time. The atoms that make up your body will outlast any difficulty you face. The energy that powers your thoughts will persist long after your individual consciousness fades. There's also something deeply comforting about being connected to the cosmic microwave background radiation. Right now, as you listen to these words, you're being gently warmed by the afterglow of creation itself. Ancient photons that began their journey when the universe was only 380,000 years old are touching your skin at this very moment. You're not separate from the cosmos. You're intimately connected to it in ways both physical and profound. Imagine floating in the gentle embrace of cosmic time, where a billion years passes like a single breath. Your consciousness is a brief candle flame in the cosmic darkness, but it's also a flame that illuminates the universe's understanding of itself. In the quiet moments before sleep, you can sense this connection, this belonging to something vast and beautiful and eternal. The knowledge that you're part of an ancient cosmic process can also inspire a sense of responsibility. You're not just a consumer of resources or a passive observer of events. You're a conscious participant in the ongoing story of cosmic evolution. Your choices, your creations, your relationships, all of these contribute to the universe's ongoing development. Every act of kindness you perform, every moment of beauty you create or appreciate, every question you ask about the nature of existence, these are all ways that the universe expresses its highest potential through conscious beings like you. You're not just in the universe. You're the universe becoming the best version of itself. This perspective can transform how you approach sleep and rest. When you close your eyes at night, you're not just shutting down for maintenance. You're allowing your consciousness to merge back into the cosmic flow, to reconnect with the deep rhythms of space and time. Your dreams become the universe's way of processing and integrating the day's experiences. The fact that you can contemplate these cosmic mysteries is itself a source of wonder. In a universe that began with simple energy and fundamental forces, matter has organized itself into patterns complex enough to support consciousness, creativity, and love. You're living proof that the universe has an inherent tendency toward greater complexity and beauty. As we prepare to conclude our journey together, remember that this knowledge is a gift. It's been passed down through generations of curious humans who looked up at the night sky and wondered where they came from. From ancient philosophers to modern physicists, from Galileo peering through his telescope to scientists detecting gravitational waves, countless people have contributed to this understanding. You're the heir to this magnificent tradition of cosmic curiosity. The atoms in your body carry the memory of stellar explosions. The structure of your DNA preserves the history of life's evolution. And your consciousness embodies the universe's endless capacity for wonder and discovery. As we weave together all the threads of our cosmic story, a magnificent tapestry emerges that reveals the deep unity underlying all of existence. What began as a simple exploration of the Big Bang has become something much more profound. A recognition that everything in the universe, from the smallest quantum particle to the largest galaxy cluster, from the briefest moment to the vastest eons of time, is part of a single, interconnected story. The patterns that emerged in the first moments after the Big Bang continue to shape reality today. The same physical laws that separated the fundamental forces in the universe's first second also govern the chemistry in your brain. As you listen to these words, the same gravitational principles that allowed the first stars to form also keep your feet planted firmly on the ground. The same electromagnetic forces that lit up the first atoms also power the electrical signals racing through your nervous system. This isn't just a poetic metaphor, it's a literal truth. The universe is a single, evolving system where everything influences everything else across vast scales of space and time. The quantum fluctuations that occurred during cosmic inflation became the seeds of galaxies, which became the birthplaces of stars, which became the forges where the elements of life were created. Those elements eventually found their way into molecular clouds, then into new stellar systems, then into rocky planets, and finally into the complex chemistry that makes consciousness possible. You are not separate from this cosmic web. You are one of its most intricate expressions. Your consciousness represents the universe's ability to contemplate itself, to ask questions about its own nature, to create meaning and beauty from the raw materials of physics and chemistry. In a very real sense, every thought you think is a cosmic event, a moment when the universe becomes aware of its own existence. The scientific method itself is part of this cosmic evolution. The same process that led from simple particles to complex atoms, to molecules, to life, to consciousness, has also led to our ability to understand these processes. Science is the universe's way of figuring itself out, and every discovery we make is a moment of cosmic self-recognition. Consider how the different scales of existence connect. At the quantum level, particles pop in and out of existence, following probability laws that seem random but actually follow deep mathematical patterns. These quantum processes power the fusion reactions in stellar cores, which create the elements necessary for planets and life. The chemistry of those elements enables the formation of complex molecules, which organize into living systems, which evolve into conscious beings capable of understanding quantum mechanics. The same principle of emergence operates at every level. Simple rules create complex behaviors, which create even more complex systems, which develop new properties that couldn't have been predicted from the original rules. This is how the universe builds complexity from simplicity, how it creates new levels of organization and meaning. Time itself is woven into this cosmic tapestry in remarkable ways. The arrow of time, the fact that we experience past, present, and future as distinct, emerges from the universe's expansion and the increase in entropy. But consciousness introduces something new, the ability to remember the past, anticipate the future, and find meaning in the present moment. Through consciousness, the universe develops a kind of temporal awareness, a sense of its own history and destiny. The dance of cosmic evolution continues around us and through us every moment. Stars are being born and dying, galaxies are colliding, and merging dark energy is stretching space itself. But these grand cosmic processes are intimately connected to the quiet moments of human experience. When you feel wonder at a beautiful sunset, you're participating in the same cosmic story that includes the birth of stars and the expansion of space. The mysteries we've explored, dark matter and dark energy, the nature of consciousness, the possibility of other universes, these aren't obstacles to understanding, but invitations to deeper wonder. The universe has revealed so much of itself to us, but it has also shown us how much more there is to discover. Each answer opens new questions. Each discovery reveals new mysteries. This ongoing process of discovery is itself part of the cosmic story. The universe seems to have an inherent tendency toward greater complexity, greater beauty, greater understanding. Through conscious beings like you, it's developing the ability to appreciate its own magnificent nature. As we float in this gentle understanding, we begin to see that the boundaries we usually draw between self and cosmos, between mind and matter, between science and spirituality, are artificial constructs. The universe is a single, flowing process of which we are integral parts. Our consciousness is not separate from the cosmos, but is one of its most remarkable expressions. The knowledge we've shared tonight isn't just information to be stored in your memory. It's a transformation of perspective, a recognition of your place in the grand cosmic story. You are both infinitesimally small and cosmically significant, temporary and eternal, individual and universal. This understanding brings with it a profound sense of peace and belonging. You are exactly where you belong, when you belong, doing exactly what the universe needs you to do, experiencing existence with consciousness, wonder and love, as our cosmic journey draws to a close. Let's take a moment to appreciate the incredible voyage we've shared together. We began with two confused scientists listening to static that turned out to be the whisper of creation itself. And we've traveled through 13.8 billion years of cosmic evolution to arrive at this peaceful moment where you're learning about your own origins. We've explored the first moments after the Big Bang, when the universe expanded faster than imagination and the fundamental forces of nature separated like dancers leaving the stage. We've witnessed the formation of the first atoms, the lighting of the first stars, and the forging of the elements that would eventually become part of you. We've marveled at the vast scales of space and time, from the impossibly brief moment of cosmic inflation to the eons it took for consciousness to emerge. Throughout this journey, we've discovered that you're not just a passive observer of the cosmic story, you're an active participant in it. Every atom in your body has been on an incredible journey through space and time. The hydrogen in your body was created in the first few minutes after the Big Bang. The heavier elements were forged in the nuclear furnaces of stars that lived and died billions of years ago. The iron in your blood was scattered across the galaxy by supernova explosions, more violent than anything we can imagine. But perhaps the most remarkable discovery is that you are the universe becoming conscious of itself. Through your awareness, the cosmos has developed the ability to contemplate its own existence, to wonder about its origins, to create meaning and beauty from the raw materials of physics and chemistry. When you look up at the stars with wonder, that's the universe appreciating its own magnificence. We've also explored the great mysteries that remain unsolved. Dark matter and dark energy make up 95% of the universe, but we still don't know what they are. The nature of consciousness itself remains one of the deepest puzzles in science. The possibility of other universes, the ultimate fate of our cosmos, the quantum nature of reality at the smallest scales, all of these continue to challenge our understanding. But these mysteries don't diminish the wonder of what we do know. If anything, they enhance it. The universe has revealed so much of itself to us, while maintaining an air of profound mystery. Like a cosmic symphony, it plays themes we can recognize, while always hinting at deeper harmonies just beyond our perception as you prepare for sleep. Remember that you're not just resting your individual body and mind. You're allowing your consciousness to merge back into the cosmic flow, to reconnect with the deep rhythms of space and time that have been playing since the universe began. The cosmic microwave background radiation continues to bathe you in the gentle afterglow of creation, connecting you physically to the moment when time itself began. Your dreams tonight might carry echoes of the cosmic story we've shared. Perhaps you'll dream of floating among the stars, of witnessing the birth of galaxies, of feeling the deep connection between your consciousness and the vast cosmos that created you. These aren't just dreams, they're moments when your mind touches the deeper truth of your cosmic nature. The atoms that make up your body will outlast any individual worry or concern. Long after your current problems have been forgotten, those atoms will continue their journey through space and time, perhaps becoming part of new stars, new planets, new forms of life. In this sense, you're not just temporary, you're part of something eternal. Thank you for joining me on this journey through cosmic time. Wherever you are in the world, whatever time zone you're in, you're part of the same magnificent story. You're made of the same stellar material, bathed in the same ancient light, participating in the same cosmic evolution. We're all fellow travelers on spaceship Earth, conscious passengers on a beautiful blue planet, orbiting an ordinary star in an ordinary galaxy. That's part of an extraordinary universe. If you've enjoyed this cosmic lullaby, a gentle like helps other star travelers find their way here. Share this wonder with others who might appreciate knowing their cosmic heritage. The universe's story is too beautiful to keep to yourself. Let the echoes of the Big Bang sing you to sleep tonight. Let the knowledge that you're made of stardust bring you peace. Remember that you're not just in the universe, you are the universe, experiencing itself through your consciousness, learning about itself through your curiosity, expressing its beauty through your capacity for wonder. Sweet dreams, fellow cosmic wanderer. The universe is dreaming through you, and your dreams are part of its ongoing story of self-discovery. Rest well in the gentle embrace of cosmic time, knowing that you belong exactly where you are, exactly when you are, in this magnificent, mysterious, ever-unfolding cosmos. The stars are singing their ancient songs, and you are part of their eternal music.